What's up? What's up? What's up? It's your boy, the network. And today's topic is Section 3.25, Configure and Verify OSPF Neighbor Relationship and Authentication. We're going to split this topic in two parts. First, we're going to configure and verify neighbor relationship, and then in part two, we're going to do authentication because it's a separate lab. I don't want to make, I don't like to put all these topics into one video. This is a topic in the CCNP route exam, the version that will expire on February 23rd, 2020. Exam code 300-101 version 2.0. Let's take a look at the exam blueprint, see where we came from, where we're headed. Is the exam blueprint implementing Cisco IP routing? Exam code 300-101. Before I even show you the topics, let's go over this again with y'all. Last day to test is February 23rd, 2020. As you can see, this is for the route exam. I have yet to take it, so that means I have to really get these videos cracking now. And after that, I got to take T-Shoot. I already took Switch. Most people take route, Switch, then T-Shoot, but I decided to take Switch first. Anyway, today's topic, again, is configure and verify OSPF relationship. We just wrapped up the section describing OSPF packet types. Again, today we are going to do neighbor relationship, split this section in two parts. We're going to do authentication after that. Then we're going to break these. Then the next section we're going to do is 326, configure and verify network types, just discussing the different network types. I may or may not do this in separate videos. That'll be a lot of videos, but who knows? Anyway, what we know what OSPF is, right? It's a routing protocol that is open source. You can use it on multiple types of vendors. It stands for Open Shortest Path First. I believe that's what it stands for. Between two routers, they have to become neighbors. They say hello to each other, then they become neighbors. But there's several parameters that has to match. Let's go ahead and look at these slides and see what those parameters are. Okay, so these are the neighbor requirements. It's just like becoming, I ain't really just like becoming a neighbor, but let's just say you move into a neighborhood that has some strict HOA rules, like the one I live in right now. You move in, you got to have this to match. This has to, you got to follow all of these rules, right? Same thing with OSPF. Interfaces of the primary IP address must be in the same subnet. It must not be a passive on the connected interface. So if I have an interface, we talked about what passive interfaces are, right? It's an interface that does not have hello messages that come across it. It must be in the same area. So if I'm in area 0, guess what? You got to be in area 0. If I'm in area, or at least an interface in both areas. If I'm in area 2, you also got to be in area 2. We can interconnect with each other through a mutual friend. That's called, I believe, an ASBR. But we'll go over those, and I believe in another topic. Hello and dead timers must match, right? I say hello by default every 10 seconds, right? And my dead timer is by default 4 times the hello. So that means what? 40 seconds. So that means by 40 seconds, if I haven't heard from you when I said hello, then I'm going to consider you dead. That's what the dead timer, or sometimes they call it the dead interval. Those have to match. So if your dead timer is 40 seconds, guess what? Mine's got to be 40 seconds. If yours is I don't know, 55 seconds, they got to match. Router IDs must be unique. In other words, if mine is quad 1 or if mine is 3.3.3.3, yours cannot be the same, or else we're just going to have a conflict. Must pass neighbor authentication. So if I have authentication set up, or if I require a password to become a neighbor with me as an OSPF, guess what? You guessed it. You also have to require a password, and that password has to match. MTUs must match. Remember, we try not to change it. So if mine is 1500, yours have to be 1500. Also, this last caveat here says, note that routers with mismatched MTUs might show up in the neighbor list. However, an MTU mismatch will prevent proper operation of the topology exchange, which means it'll be stuck in Xstart. I believe we may or may not talk about what this is in the video. We're going to launch up Boston NetSim and just do a basic single area configuration. And then we'll just run a couple show commands here. First, let's talk about, before we talk about the relationship or the process it goes through before it becomes neighbors, we need to talk about the difference between a designated router and a backup designated router. So if you look at this topology right here, this one, as you see, it says here DR, right? So router 1 is the DR. Everybody else will get their database description or their OSPF database from the DR. He is the designated router. He is the man of this network. He will be passing out information about these other routers, right? not routing table, the database description. We talked about that, what that is in the last video. And then router 2 is the BDR, which means he is the what? Backup designated router, which means if the designated route goes down, he's not going to give everybody updates on what the database looks like. Then router 2 will be back. He will be, if designated router goes down, then router 2 will start giving information about the database. So everybody gets their database information from router 2, who is the backup designated router. Everybody gets it from the DR. If he's down, then they'll get it from the BDR, right? So we need to discuss that before the process of the OSPF, open shortest path, first. So, all right, so the neighbor relationship, there are several steps that routers need to go through before they become neighbors, right? Obviously, those parameters that we talked about in the beginning, they have to match, right? First, when they become neighbors, when they say hello, they are going to be in a down state, which is right here, as you can see, down. OSPF process has not started yet. No hellos have been sent, has not been sent yet, right? Then it'll go into the init state, right? This is going to be the same thing as with a DR, but there's going to be a difference. We'll talk about that in the next slide. Init state means the router has received the hello from its neighbor. However, it does not see its own router ID in a hello packet. So when on an NBMA network or use static neighbors, this state is called attempt. So anyways, there's 7 steps it needs to go through. Just remember, they start out with down, it goes to two-way, XStart, exchange, loading, and then full. You will only become full. You will only become in a full state when with the designated router or the DR, right? And then there's the remember this is with no DR. When there's no DR, you will be in a full state, right? So with the DR, here's the difference between with the DR. The overall process is the same as without a DR. However, there are some differences. The big difference is that all routers exchange their databases with the DR and BDR only, right? This means that routers will only be full with the DR and will be in the two-way state with all non-DR neighbors. So we will be in full state with just the DR, right? Everybody else will just be in two-way. So just because you see, I'll show you an example. When you do show IP OSPF neighbor, you just look at that. You'll see, I'll show y'all when we run this show command. Here is how we configure neighbors. If you've gone to, if you've gotten to this level as far as CCNP, this is just a basic setup of neighbor configuration. You do IP address. Obviously, you have to set up an IP address on that'll if you don't explicitly say what the router ID is, as long as you have an IP address, that's why this is required. That will be his router ID, right? Then you just go into config mode, router OSPF, and then the area number or process number. This is not an area, this is the process number. So it's process number 1. Process numbers don't have to match between neighbors, by the way. And then you do the network that has to, you do the network statement. This is called the wildcard mask right here. So this is the 10 network. This is a wildcard mask. That means we don't care about this. This don't have to match. But I mean, yeah, I'm sorry. This has to match. This, we don't care what that last number is. So these first 3 octets got to match. But this last octet we don't care about. So if it's 10.1.10.00.3, we don't care. And then the area number. So, and then another way you could also configure neighbors is just going to interface and then doing the IP OSPF process number and then the area number. So this is 2 different ways we can configure neighbors, really. This is like a catch-all, and this is explicitly saying which interfaces are going to participate in OSPF. This is how we verify neighbors. Several show commands is just like the last video we did. Actually, that was for EIGRP. Or 2 videos back, that was EIGRP. So it's almost the same thing, but we're just doing show IP. I believe with IPv6, you do show IPv6 and then these commands. But anyways, that's how we verify our neighbors. We'll run a couple of these. And guess what? Boston NetSim. Let's go ahead and launch that up and get our hands dirty. Here is the topology we are going to be working with right here, right? We got pod 1 right here, router 6 is pod 1, router 3, pod 2 is on the right hand side, router 3. So this is pod 2, that side is pod 1, right? Then we got the frame relay cloud, don't really worry about that. Here is more information. We've got some IP addresses, loopbacks, etc. Let's go ahead and jump right into it. These are basic commands right here. Some show commands, and then we'll go ahead and skip this. lab task. Enable OSPF within pod 1. Pod 1 is where? Left hand side. Configure OSPF on P1R1. Let's go ahead and go into P1R1. Where's that at? Right here. We are logged into him right now. And we're going to do that on all three, actually. Using a process ID of 1. All interfaces, including loopbacks, should be placed in area 0. Serial 000 and fast Ethernet 00. So that interface and that interface is what we're going to do. Process number 1, right? We'll go and enable global config mode and then say interface FA00. Actually, we need to do the OSPF first, right? So router OSPF. He said process 1, right? And then what network? We don't even need to do all that, I don't think. We don't need to do network statements if we don't want to. So let's just do this. Let's go into interface FA00 and say IP OSPF area. Oh, no, we didn't do the area, so we do need to do that. My bad. Router OSPF 1. My bad. Router OSPF 1 network. What network is FA00 in? Let's see. Do show IP interface brief. FA00 is in the 10-100 network, so we'll just say 10. We'll just say the 10 network. We'll say the 10 network. So network 10.0.0.0, 0.0.0. Yeah, let's say 255. Area. What area did he say? Area 0. Now we are going to go into interface FA000 IP OSPF 1 area 0. I don't think we really needed to create that network statement. That's not necessary. I don't think. Right? Area 0 process 1. So let's do that. Let's get rid of that network statement because I can't remember. Remember, I'm doing this on the fly. I didn't go over this. Router OSPF 1. And then get rid of the network statement. So know that. And let's get back to interface. I believe it was the serial interface there. This guy right here. So serial 00. See, notice we got a neighbor relationship right there. So, and we got rid of the network statement. So there we go. Interface 00. So now we got to do IP OSPF 1 area 0. Right? So we did P1R1, right? Now let's go to P1R2. Where's that guy? Right here. P1R2. And then create the same routing process. So enable global config mode. Router OSPF 1 network. No, not network statement. We're going to get out of this. And I'll show y'all. Look, we created that network statement. I mean, we created the routing process, but we didn't create no network statement, right? So watch this. Show IP protocols. We're running it. And we got a router ID. So all that other stuff is not necessary. As it says routing for networks, not yet, right? But as soon as we'll check, we'll go ahead and check what networks we're going to be routing for once we put in the interfaces. So let's go ahead and go global config mode. And what networks we got to do? We got to do this one and that one, right? So that is serial 00 and FA00, right? So we're going to go interface serial 00 IP OSPF 1 area 0. That should make a neighbor relationship. Interface FA00 IP OSPF 1 area 0. Now let's do a show IP protocols and see what we've done. See what networks we're routing for now. There they go. Routing for those interfaces explicitly. So we have networks, but notice. Did we make any neighbors? Yeah, there's a neighbor right there. So we didn't make any network statements, but we did explicitly the interfaces. That's why we got a neighbor relationship. Let's so right here, do to require the same process ID in order for neighbor relationships to be established. No. Let's go ahead and do the same thing on P1R3. Where's that at? Scroll up. P1R3 is right here. We're going to enable mode, global config mode, interface. I'm sorry, router OSPF 1 router. Notice that's an ambiguous command. You got to put the R there. So OSPF 1, and we are going to get out of this and go to interface. What interfaces we got here? Come on, man. We got this, just one interface. This guy right here. What interface is that? Looks like it's FA00 is connected to switch 1. So interface FA00. We're going to say IP Ospf process number 1, area 0. These are all in area 0, right? We should create a neighbor relationship there. Let's do a show IP protocols. See what we got here. We got an FA00 interface. That's the administrative distance. Here's our router ID, which is also unique, hopefully, if they set it up to be that way. We'll see. We should do some debug commands to see how often we say hello here. Let's do that real quick. Oh, we just made a neighbor. But let's get out of that and see what happens. Debug IP Ospf. Let's do hello. See how often we say hello. PF hello. This is not really necessary, but we're doing it right now anyway. See? Receive. End of hello processing. 10 seconds. Saying hello again. So we're gonna no debug. No you all. So we turned off debugging. Okay, so we answered that question. How many, on P1R1, go to P1R1 right here, how many OSPF routes exist? How we do that? Check the routing table. Do show IP route. How many OSPF routes exist? Let's see. Let's look at the key here, our codes. OSPF, obviously start with O, so we've got 1 OSPF route, 2 OSPF routes. I'm sorry, 1, 2, 3, 4, 5. Right? We got 5 OSPF routes. What is the AD of the OSPF routes? It looks like we've got 110, 110, 110, 110. They're all 110. On P1R1, verify the new AD. P1R1, let's go on P1R1, which is this guy right here. We did that already. What is the administrative distance of the OSPF routes? On P1R1, verify the new administrative distance. I don't know what they mean by that. The administrative distance is 110. So those are the metrics right there. So whatever, we're gonna skip that guy. That goes without saying. So use the show IP Ospf command on P1R1. Let's go to P1R1. We are there. Show IP Ospf. Right? Is that what he said? Yes. What is the router ID? Where's the router ID? It is right here. ID 192.168.1.1. Why did the router select this router ID? Well, we know that it has to pick highest loopback, active loopback. If that's not available, highest IP address. Let's go ahead and take a look at the IP addresses and see what we got here. Show IP interface brief. And the highest loopback is that one. So that was the highest loopback address. He didn't pick that because that is a regular, it's not a loopback. It's an IPv4 address. These are high. This is a higher number, but it's not a loopback. It picks the highest loopback. That is the reason why. How many times has the router executed OSPF, or the shortest path first, which is the algorithm, also known as that Dijkstra algorithm? I'll put a link in the description below on what that is. How many times has it executed SPF? We'll check here. SPF is located. Let's see. Initial schedule delay 5,000 seconds, milliseconds rather. I don't see. How many times has it executed SPF? SPF algorithm. Oh, right here. Execute right there. There it is. SPF algorithm executed 9 times. That's how many times. How many interfaces are in area 0? Let's see. I believe you can do show IP Ospf interface to answer that, but they asked us to look at here. Look at this to answer that question. Interfaces. How many interfaces we got here? I don't see it. How many interfaces? Do you see it? Do y'all see it? I don't see it. He asked us to say how many interfaces are in area 0. Oh, right here, right there. Number of interfaces in this area is 2. Didn't know that. But you could also do show IP OSPF interfaces, just as a bonus command right there. So we've got 1 interface here. Scroll up. 2 interfaces there. That's also another question, right? I mean, another way to get that answer. How many areas does this router participate in? Go back to that command right there. How many, what was the answer? I mean, the question, how many areas does it participate in? Well, we know there's 1 area. So area ranges, how many areas? Is area 0. So basically 1. I don't see a summary in here. Number of areas in this router is 1. There it is right there. you use the show IP Ospf neighbor command, which we just did, I believe. Show IP, no, we didn't. We did interface Ospf neighbor. That's a simple one right there. On P1R1, display the Ospf neighbor information. Use the output the following to answer the following questions. How many neighbors does he have? Well, 1, 2. Next question. What does the full state indicate? Right there. See, it says full, full. We talked about that in the slides here. Let's go back and check. Full means LSDBs are identical and routers are fully adjacent. So once you see it full, when it says full, obviously you don't want it to say down. If they are they're not going to be neighbors. We need it to say down. So that's what full means. The link state databases are identical. So we got the same amount of information, same information, our information match, and the routers are fully adjacent. That's a good sign right there, basically. Which neighbor on the FA00 interface is the designated router? It says it right there. That's the neighbor. DR, so that's this neighbor. 192.168.2.1. Who is that? I believe it's probably going to be this guy right here, P1R2. Let's see what his ID is. Do show IP OSPF. His router ID is... No, it's not him. It's not him. Is it? Let's check his interfaces though. Do show IP interface brief. Nope. So it's going to be this guy probably. P1, P2 R1. And so it's pod 2. Enable show IP OSPF and 2.1. So that's the neighbor. Next question. Why is there no DR or BDR on P1R1's serial 0 interface? Why? Because we said it has to be, it's not a local area network, I believe. That's the question. I mean, the answer to that. Why is there no DR or BDR on P1R1's serial interface? Right there. Why is there? Let's look at the official answer. Task 3, 1D. 1D says there is no DR or BDR because elections do not take place on a serial point-to-point. So it needs to be like I believe it's called NMBA interface. So not on point-to-point interfaces. Task 4, use a show IP Ospf database. Show IP Ospf database. All right, so how many link state advertisements are shown? Types are shown. We got this right here. That's a type. And this is another type. So basically 2 types. Netlink, I believe we haven't covered what the different types of LSAs there are. I believe in another video we're going to do that in a later video. So there's 2 types really. What type of router generates a router link LSA? I believe it's a network router or router link state. We'll look at the answer to that later. What type of what type of router generates a network link LSA? So this is a router link LSA. Basically 2 types. Let's skip that. An internal router generates a router link LSA, and a designated router generates a network link LSA. So now task 4. Task 5, use the show IP Ospf interface command. Show IP Ospf interface on P1R1. Show IP Ospf interface. So we've got one interface, FA00, and keep this in mind, and serial 00. How many interfaces are configured? 2, like we just said. What is the router ID for every interface? They should be the same. Router ID is 1.1. No, they're not. Yes, they are. Router ID 1.1. Because there's only going to be 1 router ID for each router. How often are hellos sent out? By default is every 10 seconds. Let's see what it says here. Hello 10 right there. And the other one says hello 10. Then the dead timer is it's 4 times the hello. So that's why the dead is 40 on this. Dead is 40 on that. What is P1R1's FA00 address? It is this. FA00 is here. His address is that. What is the priority number for the FA00 interface? Priority number. Lord, y'all killing me here. There it is right there. Priority is 1. You know what the priority is, right? Priority is, it's kind of like a tiebreaker to let everybody know who's going to be the designated router. By default, everybody's just going to be 1. So we use that since we can't use that as a tiebreaker, we go by router ID. That's what a priority is. What is the IP address of the DR? And that's what we just mentioned. The IP address of the DR, so we'll look for designated router. See, it is right here. Designated router is 2.1, which is another router. It's not him because my router ID is 1.1. What is the interface IP address of the DR? Interface IP address it should be right next to it. There it is right there. That's his interface IP address. So this is his router ID, and this is his actual interface address. What is the IP address of the backup designated router? Right there. Backup designated router is 1.1. So which means I am the backup designated router, which is this guy right here. What is the interface IP of the BDR? Interface IP of the BDR, it should be right next to it. It's right there. 10, 100, 101. What is the serial 00 IP address? Basically the same thing. So this is serial 0 information. His IP address is this guy. What area is serial 00 interface in? Area should be somewhere in here. Do y'all see the area? Area 0 right there. So notice show IP. What command was this again? Show IP interface gives you a lot of information. Know these show commands. This will help you on the exam. What area? We said that area 0. What is the cost for using the serial 00 interface? Should be right here. Cost, 64. The cost on the other guy is, y'all see it? Okay, let's go back here. What was cost over here? It said cost is 64 right there. So the cost on the other guy is 1 because this is a fast Ethernet interface. That's why the cost is cheaper to go that way. And that was it. That is my YouTube. That is my Twitter. If you like this video, please comment, like, subscribe. Remember, the exam is expiring February 23rd, 2020. So we're going to crack these videos. We're going to try to crack these videos daily from now on, all right? Please like, comment, subscribe to the network.